Hello, everyone. In this video, we will discuss implicit differentiation. Implicit differentiation. So far, we have learned how to differentiate explicitly defined equations, where the dependent variable on one side is expressed in terms of the independent variable on the other side of the equation. For implicitly defined equations, where one or both sides of the equation may be expressed in terms of both the dependent and independent variables, implicit differentiation is used to find the derivative of the dependent variable with respect to the independent variable. For dy dx, y is the dependent variable, while x is the independent variable. First, differentiate both sides of the equation. Take the derivative with respect to the independent variable. Second, solve for the derivative of the dependent variable with respect to the independent variable. Apply algebraic techniques to solve for the derivative, and then simplify if necessary. Because implicit differentiation can get complicated, let us review differentiation techniques. Basic differentiation rules involve the following: constant, constant multiple, power, sum or difference, product, and quotient rules. Transcendental function rules refer to the derivative of exponential, trigonometric, and hyperbolic functions, as well as their respective inverse functions. The chain rule is a technique for differentiating a composite function. Where we differentiate the outer function, and then multiply by the derivative of the inner function. Or for differentiating an expression of a different variable. In which case, we differentiate the expression like an ordinary derivative, and then multiply by the derivative of the variable with respect to the independent variable. The general power rule is the extension using the chain rule of the basic power rule into composite functions or expressions of a different variable. Remember that the basic power rule is applicable when the base and the variable of differentiation are the same. For composite functions or expressions of a different variable involving transcendental functions, please refer to the following example rules. The derivative is found by getting the derivative of the transcendental function, or the outer function, multiplied by the derivative of the argument or the inner function. Examples. Find the derivative. Number 1. Y equals the square root of quantity x cubed plus y. Solution. If we try to write in explicit form where y is a function of x, the best we can do is y equals an expression involving both x and y. In this case, we can find the derivative of y with respect to x using implicit differentiation. Differentiate both sides of the equation. Then apply basic differentiation rules, such as the sum or difference rule. Because we want to find the derivative with respect to x, use the chain rule, or specifically, the general power rule, for the expression involving y. Meanwhile, use the basic power rule for the expression involving x. Solve for dy dx. Group the terms with dy dx on one side and the other terms on the other side. Next, factor out dy dx. And divide both sides of the equation by quantity 1 minus 2y. Therefore, dy dx equals negative 3x squared all over quantity 1 minus 2y. Suppose y equals the square root of x cubed plus 1, where the dependent variable y is defined explicitly as a function of the independent variable x. The derivative of y with respect to x is straightforward. Even though the variables agree, use the chain rule, specifically, the general power rule, because the given function is a composite function. And then apply the basic power rule for the remaining derivative. Therefore, dy dx equals 3x squared all over 2 times the square root of quantity x cubed plus 1. If, however, the equation is defined implicitly, but it is possible to write the equation explicitly as the dependent variable on one side and an expression of the independent variable on the other side. Then we can use straightforward differentiation as shown in the left side. Number 2. X cubed minus 3x squared y minus 3xy squared plus y cubed equals 1. Solution. First, take the derivative of both sides of the equation. Then apply basic differentiation rules. For the product terms, apply the product rule. For the power term, use the general power rule because the variables do not agree. Afterwards, differentiate using power rules when applicable. Use the basic power rule when the variables agree. Or use the general power rule when the variables do not agree. Where dy dx has been replaced by y prime in the meantime for convenience. Then solve for y prime. Distribute the constant multipliers. And then move the terms with y prime to one side and the rest of terms to the other side. Factor out y prime. And then divide both sides of the equation by the factor beside y prime. Simplify the rational expression by dividing out a common factor. Hence, dy dx is the quantity x squared minus 2xy minus y squared all over quantity x squared plus 2xy minus y squared. Number 3. The sine of x plus the cosine of y equals 3x plus 2y. Solution. First, take the derivative of both sides of the equation. Then apply basic differentiation rules. Differentiate the left side using trigonometric function rules. Remember to use the chain rule version when the variables do not agree. Replace dy dx with y prime for convenience. Then solve for y prime. Group the terms with y prime on one side and the remaining terms on the other side. Factor out y prime. And then divide both sides by the factor beside y prime. Hence, dy dx equals quantity the cosine of x minus 3 all over quantity the sine of y plus 2. Thank you for watching. Please like this video and subscribe to Professor Reginald's channel to get the latest updates.